Hello everyone. I hope you all are fine and doing well. I am Poonam Sharma. Welcome you all another session of acid, bases and salt chapter. So in previous class we have discussed about bases, their physical and chemical properties, how do they react with other substances. Apart from bases, we have already discussed about pH scale, universal indicators, and I have also explained importance of pH in our daily life, few applications of neutralization reaction, and what is the use of pH paper, how it can detect the pH value of acid, bases and salt substances in nature. So these topics I have already explained to you in previous class. I hope you have revised those topics. Now in today's class, I'll start with salt. Although I have already given a brief introduction of salt in previous class, so I'll continue with the same topic, salt. Being a combination of acid and base, they are neutral in nature and they are also known as ionic compounds. They contain both ions, positive as well as negative one. Now let's take an example of NaCl, which is sodium chloride. NaCl, when it dissociates into Na plus and Cl minus. So as you can see here, both ions, both charges are present in them. And whenever any acid react with base, we call it a neutralization reaction. And these salts are electrically neutral. And number of salts are present. Apart from number of salts, the most common is sodium chloride, which we use in our daily life, in our kitchen. It enhances the taste of food, which is also known as table salt. And if we talk about salts, all salts have some common characteristics in them. What are those common characteristics? Let's take a look. They all are crystalline in nature. They are transparent or opaque. They are soluble in water. They conduct electricity. They are different in taste, salty, sour, bitter, depending on the type of the acid and the bases present in them. Neutral salts are odorless and some salts are colored, some are colorless. So these are certain characteristics of all the salts. Now these salts belong to different families. Some have common acidic or basic radicals. They belong to same family. For example, if we talk about chloride family, it means it has chlorine in them. Look here, sodium chloride and calcium chloride. They both have chlorine in them, so they belong to chlorine family, chloride family. And if they have sulfate, they belong to sulfate family. And suppose we have calcium chloride and calcium sulfate, so they belong to calcium family. Although they have different radicals, it has calcium, it has sulfate, but they both come from the calcium, so they belong to calcium family. And here we have zinc family, in which we have zinc chloride and zinc sulfate. So depending upon the radicals present in them, we have different family of salts. If chlorine is present, it belongs to chloride. And if sulfate is present, so it belongs to sulfate family. So these are the various examples of different type of salts. Apart from this, depending on their composition, we have variety of salts. And what are those varieties? Just see here. First is neutral salt. Neutral salt is a combination of strong acid and strong base. When strong acid and base combine together, it results in the formation of a neutral salt because they neutralize the effect of each other. Being equal number of hydrogen and hydroxide ions, they neutralize the effect of each other or nullify the effect of each other, and it results in the formation of neutral salt. And the pH of this neutral salt is equal to 7. Example of such kind of neutral salts are sodium chloride, sodium sulfate, and potassium chloride. Now, if we are talking about neutral salts, it means they are completely ionizes. So it's a combination of both strong acid and base. That's why it's neutral in nature. Neither acidic nor basic shows its effect. And look at the examples of such kind of neutral salts and how they are formed. First is sodium chloride. So when sodium hydroxide reacts with hydrochloric acid, they both are strong acid and strong bases. It's a strong base and it's a strong acid. So when they react with each other, it results in the formation of sodium chloride and water. Another example of neutral salt is sodium sulfate, which is a combination of sodium hydroxide, again which is a strong base, and sulfuric acid, which is a strong acid. So it results in the formation of sodium sulfate. Another example of neutral salt is potassium chloride, which is a combination of potassium hydroxide, which is a strong base, and hydrochloric acid, which is a strong acid. As you can see, in all these three equations, water is common. And these all equations or reactions are known as neutralization reaction. These are known as neutralization reactions. Now second is acidic salt. And the name itself defines it. Acidic salt, it means it has property of acid. So which is understood, here strong base is included. So we have strong acid and weak base. Acidic salt means strong acid and weak base. So it means acid is showing its effect. So it's a combination of strong acid and weak base which results in the formation of acidic salt. And being acidic in nature, its pH is below 7. If you remember, I told you about one pH scale. This is pH scale. pH means presence of hydrogen ions, and it starts from 0 and ends till 14. Then 7 is neutral. And if its number comes, if pH scale is between 0 to 7 or below 7, it is acidic in nature, and if it is more than 7, it is basic in nature. So as you can see, these acidic salts, they have pH lower than 7. Due to this, they are acidic in nature. And examples of such kind of acidic salts are ammonium sulfate and ammonium chloride. Let's see how they are formed and what type of acid and bases are involved in their preparation. So first is ammonium chloride. It is formed by the ammonium hydroxide, which is a weak base, and hydrochloric acid, which is a strong acid. When they react with each other, it results in the formation of ammonium chloride and water. Another example of acidic salt is ammonium sulfate, which is a combination of ammonium hydroxide, which is a weak base, and strong acid, which is sulfuric acid. And it results in the formation of water and ammonium sulfate. So these are acidic salts and they are prepared like this. Next type of salt is basic salt, which are formed when a strong base is involved and weak acid is involved. So an example of such kind is sodium carbonate and sodium acetate. Look at the examples of these kind of basic salts and how do they form. First is sodium carbonate. Sodium carbonate is a combination of carbonic acid, which is a weak acid, and sodium hydroxide, which is a strong base. So when they both react with each other, it results in the formation of sodium carbonate and water is released. Another example of basic salt is sodium acetate, which is a combination of acetic acid, which is a weak acid, and strong base, which is sodium hydroxide. It results in the formation of sodium acetate. So as you can see, these are basic in nature. It means they have hydroxide ions present in them. And if we are talking about acidic salts, they have hydrogen ions in them. So how these acidic, basic and neutral salts are prepared? As I told you, acidic salts are result due to the reaction between strong acid and weak base. It means these acidic salts cannot replace the entire hydrogen from the parent acid. They retain some hydrogen ions in them, which results in the formation of acidic salt. It means some hydrogen ions are still in them. And if we are talking about basic salt, so when they react, they'll also not replace entire hydroxide ions. They'll retain some hydroxide ions in them. Due to the presence of these hydroxide ions, these are basic in nature. And the third one is neutral. As I told you, neutral salts, they are electrically neutral. It means they are combination of strong acid and strong bases. So when they both react with each other, it results in the formation of neutral salts. And if we compare their pH, neutral salts, their pH is equal to 7. Acidic salts, their pH is less than 7, and basic salt, their pH is more than 7, which I have already discussed with you. Now we have ample of salts present. And how do these salts prepare? What are their uses? And what are their chemical name? And what is their chemical name, common name, what are their properties? Let's discuss all these salts one by one. And the first salt in this category is common salt, which is also known as sodium chloride. Common salt, or we call it table salt also, because we are using this salt in our daily life in our kitchen, which enhances the taste of food. And the chemical name of this table salt is sodium chloride, and formula is NaCl. Now this NaCl or sodium chloride is formed when the reaction takes place between sodium hydroxide and HCl, which is hydrochloric acid. So when they both react with each other, it results in the formation of NaCl and water is released. So this is how this common salt or sodium chloride is prepared. And the process which is involved in its preparation is evaporation. So first we collect salty water which is present in seas in shallow pit, and due to the process of evaporation, crystals of this common salt is left behind. But these crystals contain some impurities which are in the form of sulfates of calcium and magnesium. In addition to it, they have chlorides of calcium and magnesium. So due to the presence of sulfates of, sodium, not calcium. So due to the presence of these impurities, we need to purify it, because we want pure common salt or sodium chloride. And this purification method is done by passing electricity through it. So when we pass the electricity, it dissociates and it results in the formation of pure NaCl, which we use in our daily life. For example, like when we pass electricity, it dissociates into Na plus and Cl minus ion, and HCl dissociates into H plus and Cl minus. So this is how they dissociate when electricity is passed through them. And due to the presence of chlorides of calcium and magnesium, which have deliquescent property in them, What is this deliquescent property? It means when they come in contact with air, they absorb the moisture from the air. Due to this property, due to the presence of these chlorides, this sodium chloride also has this property. So when we leave sodium chloride in open air, it absorbs the moisture. Have you ever observed when you leave salt for a few days in an open air, so it absorbs moisture, its texture changes. It is due to the presence of these chlorides of calcium and magnesium which have this deliquescent property. Now, what are the other properties of sodium chloride? Let's discuss those properties. First is, it is colorless. The sodium chloride is colorless. And the second property is, it is a neutral salt. It is a neutral salt whose pH is 7. Then, third is, it has some property which is hydroscopic property. Hydroscopic state means when we leave this NaCl or sodium chloride, it absorbs moisture from the air. This property is known as hygroscopic property of sodium chloride. Apart from this, it conducts electricity. It conducts electricity in its molten state. It enhances the taste of the food. It enhances taste of food. Then, if this NaCl reacts with sulfuric acid, it results in the formation of sodium sulfate, sodium hydrogen sulfate, and HCl, hydrochloric acid is evolved. Then after this, if this reacts with silver nitrate, NaCl reacts with silver nitrate, which is AgNO3. It results in the formation of silver chloride plus sodium nitrate is formed. So these are certain properties of sodium chloride. Like they are colorless, they are neutral, its pH is 7, it is hygroscopic in nature. It means when we leave it, it absorbs moisture, it conducts electricity in its molten state, it enhances the taste of food, and when it reacts with dilute sulfuric acid, it results in the formation of sodium hydrogen sulfate and HCl, and when it reacts with silver nitrate, it results in the formation of silver chloride and sodium nitrate. So these are the properties of sodium chloride. Apart from this, it is also used in the manufacture of various chemicals such as washing soda, bleaching powder. So these are the uses of sodium chloride. So in exam, question can come on the basis of their chemical properties, on the basis of their physical properties, and it's a 1 mark question. What is the chemical name of common salt or table salt? And the answer is sodium chloride. So sometimes question can come on the basis of its this formula also, and the formula is NaCl. So you have to learn all these points because it's a very important topic, exam point of view, and where we use sodium chloride. So on the basis of uses also, question can come in exam. So question can come in 1 mark, 2 mark, or 3 marks as well. Depends on that, you have to answer accordingly. Or sometimes question can come, what will happen if sodium chloride reacts with sulfuric acid? So it results in the formation of sodium hydrogen sulfate and HCl. And what is deliquescent property? So when any salt left in an open air, it absorbs moisture. This property is known as deliquescent property. So I hope till here this topic is clear to you. And next important salt is sodium hydroxide, which is also known as caustic soda, and its formula is NaOH. And this sodium hydroxide is a strong base. It is obtained by, or we can prepare the sodium hydroxide by electrolytic decomposition. It means by passing electricity through the brine of sodium chloride. So here one term comes, brine. Brine means when sodium chloride dissolved in aqueous solution, we call it brine. So in brine, when we pass electricity, it decomposes and it results in the formation of sodium hydroxide. And this entire process is known as chlor-alkali process. The reaction which is involved in its preparation is this. Look here, sodium chloride when combines with water, and this is known as brine. Again, it's a 1 mark question. What is brine? When salt dissolves in aqueous solution. So this is known as brine. Sodium salt plus water is known as brine. When they both react with each other, due to the passing of electricity through it, it decomposes, which results in the formation of sodium hydroxide. Chlorine gas is evolved plus hydrogen gas is also evolved. And now you can see here 2 gases are evolved during this reaction. First is chlorine and the second one is hydrogen. And this entire process is known as chlor-alkali process. Now let's see its preparation in detail. This is a beaker in which 2 electrodes are present. One is anode and second one is cathode. Now connect these 2 electrodes with the help of a battery which is used to pass the electricity through it. Here in this beaker we have taken brine, which is a combination of NaCl plus H2O. And when electricity is passed through this brine, it decomposes and it results in the formation of chlorine gas, which evolved at anode, and here near cathode NaOH, this is sodium hydroxide, is formed, and here hydrogen gas is evolved at cathode. So this is how sodium hydroxide is prepared, and so many questions can come in exam on the basis of this topic, like which gas is evolved at anode during the preparation of sodium hydroxide, and the answer is chlorine. And which gas is evolved at cathode during preparation of caustic soda? The answer is hydrogen gas. And name the process involved in the preparation of sodium hydroxide. Answer is chlor-alkali. Name of the process is chlor-alkali. So these are very important questions. And how can we prepare it? So this is the method which we use when we prepare sodium hydroxide from sodium chloride. The 1 mark question can come. Name the common name of sodium hydroxide. Answer is caustic soda. Or question can come in this way also. Name the chemical name of caustic soda, and the answer is sodium hydroxide. And its formula also you need to remember. You have to learn all these reactions in detail because question can come in any form. So you have to write this reaction. Or what will happen if sodium chloride reacts with water, or when electricity passes through it. So in this also you have to write this equation. Then we have uses of products after the electrolysis of brine. Electrolysis of brine means when electricity is passed through brine, which is a combination of sodium chloride and water. So when electricity is passed through it, we'll get these products. As I told you, we'll get sodium hydroxide, we get chlorine and hydrogen gas. And where we use them, first hydrogen gas, we use hydrogen gas as a fuel, margarine and making of ammonia for fertilizers, and chlorine is used in water treatment. It is in the manufacture of PVC, which is polyvinyl chloride, as a disinfectant. In swimming pools also we use it, in Bisleri bottles to as a disinfectant to remove or kill the germs present in the water. In CFCs, pesticides, it is also used in the manufacture of bleaching powder and hydrochloric acid. And sodium hydroxide is used for degreasing of metals, manufacture of paper, soaps, detergents, artificial fibers and bleach. So these are the uses of products which we get during the preparation of sodium hydroxide. So I hope till here it is clear to you that where we are using it. Now, apart from this, what are the properties of sodium hydroxide? First property is it is crystalline. It is crystalline in nature. It is a crystalline solid. It is crystalline solid. Then second property is it is soluble in water. It is soluble in water. So when it dissolved in water, so it is soluble in water. Then apart from this, third is talking about this property. Then we have, I'll just write here. Okay. Third property is when it NaOH, when it reacts with HCl, it results in the formation of NaCl plus H2. So as you can see, from NaOH we also get NaCl. Then again, the crystals of NaOH, sodium hydroxide, are deliquescent. Deliquescent. It means if you leave crystals of sodium hydroxide, they'll also absorb moisture from air, and they are soapy in touch. They are soapy in touch. Then apart from this, and if we leave it for longer period of the time, it absorbs carbon dioxide gas. In the presence of carbon dioxide gas, it results in the formation of sodium carbonate. So these are the properties of sodium hydroxide and where we are using them. Then apart from this, it is used in the as a caustic soda. Caustic property. What is this caustic property? Now, due to the presence of this property, it is known as caustic soda. Just write here. This is the seventh property. And this caustic property helps in breaking down the proteins. It helps in break down the proteins. It breaks proteins. So these are the properties of sodium hydroxide. Crystalline solid, soluble in water. When it reacts with HCl, it forms NaCl in water. Deliquescent, it absorbs moisture. It is soapy in touch. So when we leave it for some time in presence of carbon dioxide, it results in the formation of sodium carbonate and water, and it has caustic property, which means it breaks the proteins. And that's the reason we call it caustic soda. So this is about NaOH or caustic soda. So I hope till here it is clear. And the next salt is bleaching powder, and its formula is CaOCl2. It is also known as chloride of lime due to the presence of this. And its color is quite yellowish white in color, and it can be easily detected by the smell of chlorine. So when chlorine gas is evolved, it has some smell. So due to the presence of that chlorine smell, it can be easily identified. Now how it is prepared? So when calcium hydroxide, which is also known as slaked lime, children, you need to remember common name as well as chemical name and their formulas. These questions come in exam in 1 mark. So these are extremely important. So please learn it by heart. So when slaked lime, or we call it calcium hydroxide, was formalized CaOH2. When it reacts with chlorine, so it results in the formation of bleaching powder, and water is released. So when this bleaching powder is prepared, it also results in the formation of water. An aqueous solution of bleaching powder. It means when we dissolve bleaching powder, so it is basic in nature. And the term bleach, why we are using this term? Because it removes the color. We use it to removing the color. And that's why it is also known as bleaching agent. Because when we leave it, it oxidizes. So it undergoes oxidation. Oxidation means oxygen is added into it. So due to the process of oxidation reaction, it acts like a bleaching agent. And chlorine is responsible for this bleaching powder to act like a bleaching agent. Due to the presence of this chlorine, it has this bleaching effect. And this bleaching powder is used as a disinfectant of mass remover, weed killers. It is used for bleaching of cotton in textile industries, then wood pulp in paper industry. It is used as an oxidizing agent such as textile industries and paper industries. So these are the uses of bleaching powder. And properties of bleaching powder are, it is, as I told you, it is yellowish, white solid. Second is, when it reacts with oxygen, it acts like it makes the matter colorless. So whenever we add bleaching powder in any of these substances, it makes it colorless. It used in bleach as a bleaching agent. Then when it reacts with carbon dioxide, it results in the formation of calcium carbonate and chlorine gases evolved, which is calcium carbonate. Then we have fourth property is when it reacts with dilute acid, CaOCl2. When it reacts with dilute acid, for example, sulfuric acid, it results in the formation of calcium sulfate, water, and chlorine gas is evolved. As you can see, in all these reactions, chlorine gas is evolved, and due to the evolution of this chlorine gas, it acts like a bleaching agent. So this chlorine helps in giving in bleaching effect to this bleaching powder. And if we are talking about its properties, so these are the properties of a bleaching powder, which is yellowish white. When we add oxygen, so it becomes colorless. So these are the properties, and this is known as bleaching property. Then question can come in exam like bleaching powder forms a milky solution in water. Explain. So when bleaching powder reacts with water, it forms CaOH2, which is milky in appearance. Just look at the reaction. CaOCl2. Let's remove this one. Okay. So it results in the formation of CaOH2 plus 2HCl. I will write here so that it will be more clear to you. CaOCl2, which is bleaching powder, or calcium oxychloride. Then results in the formation of calcium oxide plus 2HCl. And apart from this, questions can come on its preparation, how we can prepare it, what is the chemical name, that is calcium oxychloride, due to the presence of oxygen, and how can we prepare it, what is the common name, what is chemical name, what is its formula, and what are its uses. So this is about bleaching powder. Next is baking soda, or we call it sodium hydrogen carbonate. Baking soda is sodium hydrogen carbonate, which is also obtained by chloralkali process. If you remember, in one salt also we use this chloralkali process. Do you remember that process? In the preparation of this one. This I have already explained. In the preparation of NaOH. So in the preparation of NaOH, sodium hydroxide, we use this chloralkali process. And in the preparation of baking soda also, we use this chloralkali process. And the chemical name, extremely important question, chemical name of baking soda is sodium hydrogen carbonate or sodium bicarbonate. And we use this baking soda in making cakes, bakery products, or in making some other sodas also. So we use it. It is used as an antacid when we feel acidity, when we have acidity due to indigestion. So in that case, we use this baking soda as an antacid. So we use this baking soda as a fire extinguisher also. So we'll discuss these uses later. First, how we can prepare this baking soda. It is obtained by brine. Again, what is brine? Solution of sodium chloride and water is known as brine. So due to the reaction between brine, carbon dioxide and ammonia, it results in the formation of ammonium chloride and sodium hydrogen carbonate, or we call it sodium bicarbonate. And this process is known as Solvay process. The process which is involved in its preparation is known as Solvay process. As you can see, sodium chloride and water, which is known as brine, when it combines with carbon dioxide and ammonia, it results in the formation of ammonium chloride and sodium hydrogen carbonate or sodium bicarbonate. So in this manner, we'll get this sodium hydrogen carbonate or baking soda. Now, what are the properties of sodium bicarbonate? Let's see here. It is white crystalline solid, but it appears like a powder. But if you'll see here, these are white color, and it is amphoteric in nature. It means it has both the properties of metals and non-metals, so or acidic or basic. So they are amphoteric in nature. Then it is sparingly soluble, means it will not completely dissolve in water. So thermal decomposition of sodium hydrogen carbonate is required. So when we provide heat, then only there is a breakdown or the decomposition of this sodium hydrogen carbonate takes place. But if we are talking about other salt which we have discussed earlier, they dissolve in water. They are soluble in water. But this baking soda is not dissolved in water. It is sparingly. Only a few amount of the salt can be dissolved. So by thermal decomposition means by passing heat. If we provide heat, then we can easily break it. So when this baking soda is heated, it decomposes into sodium carbonate, carbon dioxide and water. So sodium carbonate formed after this thermal decomposition decomposes into sodium oxide and carbon dioxide. And this reaction is known as dehydration reaction. So these are very important topics. So I hope till here it is clear to you. So what is dehydration reaction? When we heat this sodium carbonate or by providing heat, so it removes water and then it becomes sodium oxide and carbon dioxide gases evolve. So thank you everyone. I hope till here it is clear to you. Just revise all the topics thoroughly and we'll discuss other salts in next class. Till then, bye and take care.